Welcome to Astronomy 100. We are fortunate in that there is no follow-up course to Astronomy 100, so there is no real obligation to prepare ourselves to meet the demands of a course that might come next. We have a certain amount of freedom to define this course to mean the thing that we want it to mean. And we will have this course directed towards the awe and wonder and the mystery of the universe. We will use a very minimal amount of mathematics in this course. What we will do is explore the excitement of what is out there. My measure of success in this course is if I can get you to say, wow, 4 times in this course, then I will feel that this course has succeeded. I'll give you an example of a few such items. First, tonight, if you go out and take a look at a star, and you say, I'm seeing that star, the light's coming into my eye. However, even the very nearest star that's out there, it took that light 4 years to travel from its origin at the star into your eye. Do you have any more recent information about that star than took place 4 years ago? That's the most recent information you can have, because it takes 4 years for the light to travel from that star into your eye. That star could have not been there anymore, and many other things could have happened to it, and there's no way that you would know about it until 4 years after the event. Let's call it the look-back time. Now, with large telescopes, we can look back 1 billion years. So what we see is the situation as it was 1 billion years ago. And you say, well, that's disturbing. Can't we reach far out into space and see it the way it is right now? No, because it takes 1 billion years for that light to reach us. So we can only see that part of the universe as it was 1 billion years ago. There's no way that we can get any more recent information. And you might say, well, that's a bummer. But actually it turns out to be a plus, because there's no reason not to assume that that part of the universe is any different than our part of the universe. So as we see the way that part of the universe was 1 billion years ago, we also are seeing the way ours was 1 billion years ago. So with our look-back times, we have an automatic progression back into our own history, and there would be no other way to gain this information. Now, the third item I'd like to bring to your attention is one of our very largest planets, Saturn. It's the one that has the rings around it. And it's such a large planet that you might think it would be very dense. And by density, what we mean is the thickness of the object. For example, a brick and a piece of wood are of the same size, but the brick is much denser or thicker than is the piece of wood. And actually the brick would sink in the bathtub and the piece of wood would float because it has less density than that of the water. And the interesting thing about Saturn is even though it's a giant planet, if you put it in your bathtub, good luck, it would float because it is that less dense than water. So even these giant planets are sometimes not what you might think they are. And the same is true for our sun. Our sun is not a solid. It's actually a gas ball. So even at the very center, the molecules do not touch each other. The atoms do not touch each other. They're in the form of a gas throughout the entire sun. And there are future things that can happen to a star. After it ceases burning up all of its internal fuel, it starts to shrink down and down and down. And it gets denser and denser and denser. And there are stars out there that have shrunk so far down that if I took 1 teaspoonful of the material from that star, the weight of it would be 100 million tons. 100 million tons in a teaspoon. And that's an object that's out there in the universe. That's not our Earth, of course, or our sun, of course, but it is an object that you can study in another part of the universe. And the final piece of information to leave you with is our sun is 5 billion years old. We're fairly confident of that. as is the age of our planet, because we're both created out of the same dust cloud at about the same time. Our sun is about 50% through its lifetime in middle age. In another 5 billion years, our sun will start to die. And one of the early things that it does when it starts to die is it swells, it expands. It will expand until it is out past the orbit of Earth. That is, Earth will be inside the sun. And the surface temperature of the sun is 3,000 degrees. So things will change very, very much for us at that time, 5 billion years. You just wait for it. Okay, those are the types of things that we're going to explore in this course. And we're going to spend 8 weeks discovering the excitement, the mystery, and the awe of the universe that's out there.